Hello, this is Professor Hester. In this video, we'll discuss OSI Model Layer 3, the network layer for CCNA networking. We'll first look at Layer 3 functions, then we'll examine IP packets and how they are processed as they move through a network. Layer 3, the network layer, moves data between remote networks. Its PDU, or Protocol Data Unit, is a packet. The source host creates the packet, and it is mostly unchanged as it travels throughout the network. Layer 3's characteristics are, it is connectionless. Layers 4 and above manage connections between the source and destination devices. It is also best effort. If a packet gets lost or doesn't arrive, Layer 3 doesn't try to resend it. Layer 4 and above manage this if desired. Finally, it is media independent. Layer 3 doesn't know what physical media will be used along the route. Layer 2 creates frames for the specific media, and Layer 1 handles the physical transmission. Let's look at 3 types of Layer 3 protocol functions and what they do. First are protocols to figure out how do we get there. These are called routing protocols, and they select a path to get a packet from one location to another. You'll learn how these work and how to implement them later on. Next is, can I get there? These functions, ping and traceroute, are part of ICMP. They are used for troubleshooting to determine if a remote location can be reached. Finally, we need information about neighbors on our local network to support Layer 2 functions. We use ARP, or Address Resolution Protocol, in IPv4 networks, and ICMP v6 Neighbor Discovery in IPv6 networks. Each of these protocols finds our local neighbor's MAC address so that we can build a Layer 2 frame. The network layer addresses are logical addresses. We have 2 addressing systems, IPv4 and IPv6. A logical address means the address changes depending on which network the device is currently on. Your laptop's IPv4 address will probably change when you move it from your home network to your school or work network. A Layer 3 address tells us 2 things: the network a device is on and its unique ID or host ID on that network. This is similar to physical addresses on a map. Googleplex is located at 1600 Amphitheater Parkway in Mountain View, California. The street address is like the host ID. To locate the building, we need more information. We also need to know the city and state where the street is located, similar to the network ID for a host. Now let's dig into IP packets and see how they move across a network. When Layer 3 receives a Layer 4 segment, it encapsulates the segment into an IP packet. The packet has either a 20-byte or 40-byte header with information for routing the packet. Here are the most important fields and how they differ between IPv4 and IPv6. Source IP address is who created the packet. Destination IP address is the final destination. DiffServ, or traffic class, is used to prioritize traffic for quality of service. Voice and video traffic may be prioritized because they are time sensitive. TTL, or hop limit, is used to prevent loops. Each time a packet is forwarded, TTL is decremented by 1. If it reaches 0, the router will discard the packet. As the packet moves throughout the network, the IP addresses do not change. However, the TTL or hop limit is decremented at each router. Let's see an example of how a Layer 3 packet travels through a network. Here, PCA sends a message to PCB across 4 networks with 3 routers. First, PCA creates a Layer 4 segment and passes it to Layer 3. PCA encapsulates the Layer 4 segment into an IP packet containing a destination IP address, a source IP address, and TTL. The destination address is PCB's, and the source address is PCA's. Here, TTL is 10. PCA forwards the packet to the first router, R1. R1 verifies that TTL is greater than 0 and looks up the destination IP address to PCB in its routing table. Now R1 decrements the TTL from 10 to 9. It forwards the packet to router R2. R2 receives the packet. Like R1, it verifies that TTL is greater than 0 and looks up the destination IP address to PCB in its routing table. R2 decrements the TTL from 9 to 8 and forwards the packet to router R3. R3 receives the packet. It verifies that TTL is greater than 0 and looks up PCB's route in the routing table. It is a directly connected route because PCB's network is connected to R3. R3 decrements the TTL from 8 to 7 and forwards the packet to PCB. PCB receives the packet. It de-encapsulates it by removing the Layer 3 packet header and passes the segment to the Layer 4 protocol. Let's review what we talked about in this video. What 2 things are contained in an IP address? IP addresses have a network ID and host ID. What part of a packet header is modified along the route? The TTL is decremented. What does the destination device do? The destination device will de-encapsulate the Layer 3 packet and pass the segment to Layer 4. Here is a summary of the quiz questions with the answers. And I hope this discussion about the network layer was helpful to you, and I'll see you in the next video.